What about now? Can you hear me now? Is that better? Alright, let me know if that's better. Hello? Okay, perfect. Um, so, yeah. So here's the rocket that I just did the hold down test on. it went really well, and I'm super excited to fly it. But first, we need to design the parachute system and a mount for the flight computer inside of the rocket. So, this rocket, like the whole thrust vectoring part, works through the code that's on the flight computer. And then the flight computer controls how the gimbal actuates the rocket motor. So basically how the code works is we've got, I think, 5 main functions. And functions are just like blocks or like chunks of code that you can call like whenever. So you can just say, write one line of code, and then that will run your function, and your function's like a bunch of lines of code. And so you can write one line of code to write a bunch of lines of code. It sounds really complicated how I'm explaining it, but like basically it just runs off of a few main functions, which are idle. We have idle, and then that's when it's just sitting there on the pad. And then after idle, like after it's launched, we have powered flight. And powered flight, that function is where we're thrust vectoring and waiting for the altitude to start to drop, so that we know to deploy our parachutes. And so as the altitude starts to drop instead of increase, it starts to decrease. When it decreases, the powered flight, this function will go into the unpowered flight. And so this function, what happens in this function is that the parachutes will deploy, and then it'll detect for when it's on the ground, and then it'll go to idle again. And so that's basically how our code works. And so right now we've got most of this part working. So like that idle and the powered flight, that's all working. But for the unpowered flight, we don't have a parachute system for our rocket yet. So we need to work on that today. We're going to design like basically how it's going to work and everything. So if we've got our rocket, right? And so we'll say that's our rocket. It's got its little thrust vector mount down here with the little rocket mount thing, motor, yeah. And then the 2 servos, and that moves back and forth. We've got all that working, and then in here we'll have our flight computer, which we need to design a mount for in the rocket, so that it's not just sliding around and stuff. And then we need to have a parachute, right? We'll say that's our parachute. And so our parachute needs a way of leaving the rocket, right? So there's a few ways we can do this. One way is we could have a little explosive charge right here, right? And then that would blast the parachute out along with the nose cone that'll be up here, right? That's one way to do it. But it's also like the dangerous way for your rocket, and I don't want my rocket exploding. So I don't think I'm gonna go with that idea, right? But then there's a mechanical way that we can do it, right? We could have our rocket, our gimbal down here, cool, our flight computer, and then up at the top we could have our parachute, and then we could have like some sort of like wall here, and then put a spring going here, and then have that spring held down by something like a servo motor, right? And then when that servo motor turns, that spring is released and it could launch our parachute out. That's like a reasonable way to do it. If you guys have any ideas, please let me know. But I think I'm gonna go with this way because I don't want to be blowing up my rocket. You know, like, does that make sense? Did any of what I just said make sense to any of you? Like, or did that go like way over your head? Cool. All right. Let's just erase this. So, oh, I bumped the camera. We need to design how this is going to work. And so I was thinking, normally the parachutes come out of the top of the rocket like this, right? But what if our rocket was special and we had the parachute right here, and then the parachute came out of the side? Wouldn't that be cool? And so, like, as our rocket's falling to the ground, right, it's just got the parachute hanging like this, you know? Instead of, like, having it hanging from the top. That's what I was thinking. And I think that would be cool. And my whiteboard, well, piece of plexiglass on a piece of poster board keeps sliding around a lot. So, like, sorry. But that's what I was thinking. Oh, my dog. Poor puppy. Oh, goodness. All right. So, let me know if you have any thoughts on that idea. And I will be working on, I think it'll be really cool to have the parachute come out of the side instead of the top, because it'll make it like cool or whatever. So I think we should just start drawing. So, oh, that sound. Everybody's favorite sound in the world, you know? Alright. We're gonna draw a rocket. And then here we've got our gimbal. And then we'll have our little rocket mount, or rocket motors sticking out of that. And then our servos will be there to actuate it. And then here we'll just put our flight computer. We'll say it's right there. And then up here we're gonna need our parachute. So we'll kind of try and draw it all right, but it's all wadded up and like wrapped in its string or whatever. And we need first of all, we need a way to attach the parachute to the rocket, so we don't just launch the parachute out and both the rocket and the parachute fall to the ground, right? So we need some sort of like something to attach it to, and generally, yes, dog. Generally, it is better to have like some sort of rod inside the rocket instead of trying to like glue it in or tape it in, because like glue and tape sometimes fail, but like knots around like a stick or whatever don't. So I think if we take like you know, like little shish kebab sticks. Here, wait, I'll grab one real quick. I've got one over here. So a shish kebab stick like this. So we could actually take a couple and tape them together so it would be stronger, because it will be like 3 inches across, and this is fairly breakable, but I feel like if we had 3 of them taped together, it probably wouldn't break. So here, I'll grab 2 more. All right, I have 2 more. So yeah, if I just tape these 3 together and then like stretch them across my rocket like that, then we could tie our parachute onto here, and that would be fairly sturdy. Good idea. Thank you, Blip Blop. I know, I try to have good ideas. Okay, so yeah, I think this will work as a way to attach it, but the only issue that I'm thinking about is how do I attach this to the rocket? Like, I could cut a hole through it on each side, cut a hole, and then like put it through and hot glue it, and then cut off the ends. I just really don't like using hot glue because it's so janky. But that should work, I think. And then, so we'll have this attached on the inside, and then we'll tie our parachute to this, and then we can, and then we'll need a kind of like a door on the side of the rocket, because we don't want just like a big hole, or else that would like create a bunch of drag. So if we make like a part of our rocket that can kind of like fold up or whatever, and so it's just kind of loosely hanging down like that. And then when our spring pushes it out, it'll push the door open. And then it could fall down. We might want to have something that's holding this closed to like the wall of the rocket. Blip Up said, hot glue is hot. Yes, it is. Hi, Starduck. Tested. Cool. Okay, so we'll have this door somehow held in here. We could have a rubber band. Yeah, we could have a rubber band attached to our, like, shish kebab things that go across. Here, I'll just draw a dotted line. We could have a rubber band attached, like, back here. And then it could be connected here. So then that rubber band will pull it back closed. That should work. I'd only worry that it would interfere with the parachute being able to come out. Like the parachute hitting the rubber band. But if we put the rubber band on like the side of the rocket, so say that's like our... Ooh, that's a... I'm not very good at drawing. Okay, so if we've got our rocket like that, just like pretend that my drawing looks decent, and so it's on like the side here, and then this will be in the middle. That should work. What else do we need to take into account? We'll probably just have like a fold here or a bend in the paper so that it can allow itself to just kind of, it's kind of its own hinge. All right, and then what else? So we need to now design our like actual parachute pushy out thing. So let's say we like flip the rocket around, and our door is now over here. So we'll have our parachute in here. I'll wad it up, or should I say, I don't know. And then we'll have our spring that's back here. Should I do a spring or should it be something else? Any ideas for things other than a spring? Because a spring's kind of boring, but it would work. Anybody got an idea? You should work at NASA. I should. A spring. Okay. I already have that idea, Starduck. Any other ideas? It's reusable. Yes, a spring is reusable, and pyro charges are not reusable. And my rocket won't blow up because I have a spring in it. What else? Like, we could do... Alright. A slinky. Slinkies aren't... How would a slinky work? What? A slinky's just, like, it doesn't push out, it just, like... It, like, does the opposite of a spring. What's your thought process? Maybe a kind of bouncy surface to... What? It will slink. Okay. We're gonna move on from the slinky idea. We could use compressed air somehow. We could have like a little compressed air cartridge in the bottom, or like down here. And then we could have a little hose that goes out here, and then a pushing mechanism. Oh, that's a great idea, Brysonator. A Minecraft piston. Like a PCB that, like, presses off it? Or a PVC. What? What is PVC? Okay, we're gonna move on. So if we've got a little can of compressed air, right, and then a little electronic switch that we can trigger, and then a nozzle that could push out our parachute, that's a possibility. We just have to add the extra weight of this compressed air cartridge, which would make our flight go less high. Do you have an air pressurizer? You mean an air compressor? Yes, I do. I've got 2 of them, actually. I have 2 air compressors. But I don't have a little air tank like this, so I would need to find one. But that is a possibility. I just don't think it's as practical on such a, like, small-scale rocket. Well, I mean, nothing I'm doing here is practical, but I feel like it would make it less cool because it would go less high. Whoa. Okay. What are you woeing to, blah, blah? So, if we could go with a spring, I think the spring is our best option right now. We could probably find a fairly large spring for pretty cheap on, like, Amazon, because Amazon has everything, you know? Okay, Starduck says use a cheap chemical reaction because it can produce more force than Smith that uses gravity and motion. Okay, so a cheap chemical reaction, what would you suggest the cheap chemical reaction be? And also, chemical reactions aren't reusable, so in the long run, springs would be more like cheap in the end because I could use it like forever. Like magnesium and put it under dry ice. Well, that would be an issue because first of all I had to obtain both of those materials and I'd have to keep the dry ice cold in the rocket, and I'd have to have an area for the dry ice to be. That's why you said cheese. What? Okay. What? I thought you just misspelled cheap. And I don't think, I don't know, I'm not familiar with the reaction you're talking about, so I don't know if it would produce more force. That's a decent idea, though. I just don't think those chemicals would work. I don't know of any other chemical reactions that are safe to use and wouldn't result in my rocket blowing up, you know? So far, spring is our best idea. Can anybody top spring? Anybody? Alright. So, I think spring is the best idea. I think a servo here, that's got its little arm sticking over the spring, would be good. I would worry about the, like, tension. I don't know what the, like, technical term is, but, like, when you, like, push on something, it's harder to, like, move to the side or whatever. So, I would worry that would be too much for the servo, and the servo wouldn't be able to turn, or that this piece right here would break because of the power of the spring. But we could do something that might work. Okay, I've got an idea. If we've got our rocket, oh, that's a tiny door. All right, we've got a rocket, and then we've got a servo here with the arm extending this way. And then here's our spring, right? And then we have used purified oxygen, then lighter fluid. Real quick, I'm gonna Google how expensive purified oxygen is. Are you talking about like liquid oxygen or? And use the isolation product to keep the heat and use. I think he is. I think Starduck is trolling right now. So like, I don't think you know what you're talking about. I'm sorry to say it. And use the isolation product to keep the heat and use a narrow exit so that it builds up a lot of pressure and blasts off. So you're talking about building a rocket inside my rocket. Is that what you're talking about? Purified oxygen and lighter fluid. Yeah, he's trying to build a rocket inside of my rocket to blast the parachute out. I don't think that's the idea I'm going to go with, but I like the creativity. Okay, if I have a little like 3D printed thing here, or actually the servo wouldn't be extended out that way. It would be extended out like forward or backwards in that direction. And then if we've got a little 3D printed piece that's like right here, and then just use a spring. All right, I probably will blah blah. And then if there's kind of a support going into the wall here, and then actually that's not how I wanted to draw it. This would come out to here, and then there would be like a small pin or something that goes into here. so that this, here, let's draw it from a different view. Here's like a side view, and then here will be our front view. Actually, I need a bit more space. So here, I'll get rid of this. So this will be our front view. So like, say we're looking in through this window right here. So we'll have our servo. So, as I was saying, we'll have a servo like right here, and then its little thing coming off this way, I think. That's... Oh, I see. I did it wrong. Alright, and then the servo, what's this called? I don't, there's a lot more potential energy. Oh, Starduck. It goes super duper high. Okay, wait. Starduck, are you talking about the rocket engine, or are you talking about the deployment system, the parachute deployment system? Because I think you're talking about the rocket engine. Using purified oxygen in a little separate tank at the bottom with a fuel source will have so much potential to be used to go straight up. Engine. Okay. I thought you were talking about the parachute deployment system, because that's what this stream's all about. But thank you for the ideas. I think I'm gonna stick with solid rocket engines for the time being, because I don't want to blow my house up. You know, just kind of a slight. Just use a spring, LMAO. Okay, well, that's what I'm trying to do. Okay, so we've got our servo here with the little plastic thingy. I don't know what this is called. This has been bugging me, because yesterday I was trying to figure out what it was called. The little, like, plastic thing that comes off the servo. If anybody knows, let me know. And then here we've got our spring, right? And then there's this thing right here, which kind of is connected to the wall. And then in here is a little pin that sticks out into this piece. And then as the servo turns this way, it'll push this piece out of the way. And then the spring should be able to come up. Does that make sense? Does that make sense? Use a motorized Bluetooth controller to open and close the little trap door at the side. I thought about it. That could work. Actually, I would probably put the servo. The spring will go boing boing and push it out the parachute, and will end up making go awesome possum. Okay, so I was thinking if we have a servo in here that's got its little plastic thingy, still don't know what it's called, with a string that's connected to our door, and then the servo could pull it up, right? And then the door would come open, and then the parachute could come out, right? That's a possibility. Same, Bryson. There, I think, I don't know, I feel like that might just be overkill, because we could just have our little rubber band down here, and then have the thing just push itself out, instead of having to have a servo that pulls it up, and then Yeah, I feel like that's just too much overkill. Even though this rocket is completely overkill, but like you know, I think I think it would be. I don't know how to phrase this because everything about this rocket is so like pointless. But like I don't feel like doing this, so I don't think that is the idea. But thanks for the idea, anyways. Um, but does this part make sense? So we've got this servo that'll turn and then push this little thing that is like connected here, and then it'll spin that way and allow the spring to come up. So like here's our side view. The servo will come and push this out of the way so that our spring can pop out. That's what I was thinking. I feel like I hope that'll work going up. I don't think there's anything that should be able to like nothing, no force should be able to like push it open or whatever. And yeah, so and then here we'll have I might make a little we could make a little bowl, or actually we should definitely have some sort of like wall here um so that our parachute doesn't like slide down or whatever. So then our door is like here, and then we could actually have a little 3D printed wall here that can slide back and forth, and then that could be what pushes it out, because this small spring wouldn't have very much surface area to hit the parachute, and if it like misses or something, then that wouldn't be good. But if the spring pushes this wall, and then that wall pushes the parachute out, then the parachute will definitely come out, and then we could have a slight hole here for the parachute strings to go, and then we'll have our shish kebab sticks up here, and that'll be attached to that, and our rubber band here will also go in there and attach there, and then that'll pull that back in. All right. If we make the parachute system too heavy, can't it actually accidentally tip the rocket over, or is your engine enough to correct that? That is a good point. If our parachute system is too heavy, and like it's super top heavy, if the rocket's super top heavy, then it would start to tip because the heavier side would go down. But I just got marker all over my hands. But I think this is pretty heavy, and our flight computer will also be in the bottom of the rocket. So that's going to be most of our mass. And this won't be very heavy at all. I think the heaviest thing will be like the little wall here. But even that's not super heavy. It's a good point though. And yeah, the thrust vector control system should be able to correct for any slight pitch and yaw. Yeah, so I think that's everything we need with the parachute. I'll just have, I don't know, how big of a parachute should I have? I'm going to Google it. How big of a should a model rocket have? Because it's a pretty big rocket. So it says rockets 18 to 24 inches use a 12-inch or an 18-inch chute. Rockets 24-inch and taller should use an 18 or a 24-inch chute. So I should probably go for a 24-inch chute because this is a big rocket and it's got a flight computer in it, and I don't want that turned into a pancake. So, that's our goal. And I should be able to find one of those online and just order it. And then, does anybody see any problems with this design? So we'll have the parachute in here, wound up, and then one of the ends tying up here. And then, so if we make this, we'll probably want to center this as much as possible in the rocket, because we want the rocket to fall like sideways, like, here, I'll show you. We want the rocket to fall like this, instead of like this or whatever, or like that. It would be cool because like, oh, but we also have to, we'll want it at our center of mass once the rocket's fully done, because even if it's at the very center, then still like our heavy parts will like tilt the rocket. Startup, you found a lot of problems. I'm excited to hear about these. All right, well, give me a second. I'm gonna take like a quick 5-minute break to go get some water, and then I'll be right back. Okay. I hope you can hear me. If you can't, well, that would be kind of pointless because you couldn't let me know if you couldn't hear me. So, Starduck, You said you aren't using a motorized Bluetooth controller for the hatch at the top side of the rocket to make it go boing, boing, boing. So I'm using an autonomous controller to make it go boing, boing, boing. So that's even cooler. Like, I don't even have to use Bluetooth to press a button, you know? And he said you aren't using purified oxygen. Well, you see, I'm muted? No, I'm not. I highly doubt that because I see my voice. I can see it. You're not getting me this time. All right. Purified oxygen is really expensive. And I mean, it would be really cool to make a it would be really cool to make a liquid rocket engine sometime, but like I wait. Are you guys? Give me a second. I'm gonna be frustrated if like you can still hear me. Oh really? Yeah? You sure about that? I don't think I am. Hello? Hello? Oh wait, I should probably... I don't think... Yeah, I'm not muted. I can hear myself. Haha, take that. Okay. As I was saying, I'm going to, like, ban that statement in my YouTube chat, like, after the stream, because that's not nice. Okay. So, we've got our parachute ejection system all mapped out. We need to figure out materials and sizes for things. So this is obviously going to be a servo motor, and then that's pretty basic. We need to, I'm going to do some research and find the best spring that should be able to fit into the rocket. Apparently Starduck's muted. Yeah, so we'll need to find the best spring that'll be able to fit into the rocket. And then I'll 3D print these parts here, which I'll have to design in CAD. That should be pretty simple. And then I'll just have a little like bolt that goes into here. That should all work out. And then I don't know what to make these little walls out of, and this wall. I could make it out of cardboard. I could 3D print them. I could just make it out of like cardstock or like note card paper, because that's pretty thick. Oh, I dropped my cap. I have to go grab it. All right. Do you guys have any ideas for what I can make it out of? And not liquid oxygen, please, because that's expensive. You're purified oxygen. I'm purified oxygen. You're saying that I'm... Okay, interesting. Okay. You would have found it faster if you used purified oxygen. But you mean I would have found my cap? It was right over there. Okay. What should I make these walls out of? I could definitely 3D print them. Like, I could 3D print them kind of like this. This was the old flight computer mount. This was going to be the flight computer mount for the first Grapefruit flight computer. But as you know, that flight computer didn't really work out. Do you guys want to see the old flight computers? I don't think I actually I don't think I've ever shown one of them in a video yet. Okay. So, show us. Yeah, I will. This is the first one. I had to take the IMU off because I needed to reuse it. At the time, I only had one of them. But yeah, this was the first one. And, wait, was this the first one? I think so. Yeah, this was the first one. And I could never find anything wrong with the wiring back here. But like now that I look at it, it looks really janky. And I'm glad I'm not using this. But yeah, I could never get it to work. I'm not muted. Okay, and then this was the second one. I don't think I've actually shown this in any videos. Like the exact same thing happened. Like I only got good measurements from the IMU, and I couldn't get the servos to turn even with different code. But yeah. So then I finally decided to, like, I did a bunch of tests. I completely rewrote my code because my code stopped working. That was a fun time. The library I was using in my code just like wasn't supported anymore. So I had to completely rewrite my code. But then I finally settled on this mounted on top of the Arduino Uno, and it's really cool. And it works. So that's a plus. It took me like an hour to put together versus these, they took me like 4. So I don't know why. I don't know why these don't work still, but like I keep them. Don't tell everyone lies. Yes, show us. You're muted. My library. You wrote the library. It was me and YK. What? Okay. Startup thinks he wrote the library that I was using, and that no longer works. What an odd character. Okay. So, oh yeah, I was gonna show you how it fit in here, but I already put it away, and I don't want to. But yeah, I could just print something like this, and then put it in here, and then put it on both sides. And then that should keep the flight computer in without, or not the flight computer, the parachute in without it like falling down to the bottom or the top of the rocket. And then we could, almost just print. Well, actually, this will be difficult because it'll have to be small enough that the curve of the rocket doesn't prevent it from going forward. Because the rocket's curved, and if you try and push like a flat thing into it, it'll run into that curve. So how could I could use a piece of paper that could just bend. Yeah, that's a good idea. I'll just make this out of like cardstock or whatever. And so when the oh goodness, what is it called? When the spring pushes it out, it'll just like bend as it reaches the curve of the rocket, and that'll push the parachute out. All right, I like that. So, what else do I need to plan for this? Am I missing anything? I know Stardust is gonna say you're missing oxygen, but like, I think that should be good. I'm going to maybe I'll start designing the flight computer mount because that's something that's important, and I need to make sure that I get that in and that's designed well so that our flight computer doesn't like fall in and burn. That's probably good. Oh, we should probably... No, none of that needs dimensions. I'll figure that all out later once I choose my spring. Okay, see you, Brysonator. So we need our flight computer mount. So currently, our flight computer is let's say 2.5 inches by 2 1/8, and by, let's see, 1/2 inch. And so we need a mount that can hold this and then fit into our 3-inch rocket diameter. Oh, that's a bad 3. There we go. 3 inches. So it'll probably just be, this will be our top view, and we'll have a circle that's just 3 inches. That should be pretty, like, normal. Do you think I should add, like, these cool bits and bobs things on it? Like that? Like these, like, weird hexagon things? Or should I just leave it flat? Because I kind of like the weird hexagon things. I'll like print it with better quality because this was pretty bad. And then at the top it says grapefruit. I don't know if you can see that, but it does. It didn't print very well. So this will be our top. I think we should add the hexagon things. So like loop. Those are pentagons, but like whatever. This isn't geometry class, so it doesn't matter. We'll have those weird things, and then probably we'll have a hole here and a hole here. So that'll be like the top and bottom piece. And then looking at it from the front, we'll have this like kind of from the front view, and then this at the bottom. Here, I'll redraw that. And then we'll have those 2 holes in here on each side, and we can have 2 like structure poles, like dowel rods almost, going through here. And so I think these dowel rods will just rubber band our flight computer onto those dowel rods like that. And then that should be strong enough to hold it together, as long as we make sure it's like rubber banded tightly on. And then it'll be easy for us to remove the flight computer. Do you guys think that's a good idea? Let me know. Also, I think it'll be best if I have access to the flight computer while it's mounted inside the rocket. So here, let's get rid of this. So yeah, we'll have those 2, that and that, and then we'll have our dowel rods coming down. And then we'll have the flight computer rubber banded to it. And then, no horrible idea, you need purified oxygen. Okay, find a way that I could use purified oxygen to secure the flight computer into the rocket, okay? Once you do that, let me know, and I might add it. But so we've got our flight computer mounted here, and then we need to be able to access our flight computer from the outside. So in our rocket airframe, we should probably, where am I going to draw this? Over here. So in our airframe, we should cut out like a hole here and then be able to like peel like this over, and then if we have a fold here, so it like folds over like that, and then we will be able to access our flight computer and see like all of the I'm going to add lights, a button, and a couple more sensors to this, and a beeper before it's finished and we like do the flight. So like the light will determine what function we're currently performing, so idle, powered flight, or unpowered flight, and then the beeper will be like it'll kind of act as our countdown, and then I'm also going to add a barometer so we can detect our altitude, which is something big that I need to do, but I'm going to work on that in the next couple of weeks. So, as I was saying, we'll have this come down from our from the airframe. We'll have this kind of peel off, and then we could have like a piece of tape here, or like a magnet or something that holds it up when we're flying. And then I think that should be it for the flight computer mount. There's not too much we need to do with that. Because, I mean, it's really just holding the flight computer in, and then we'll have our wires going down to the thrust vectoring mount, and then up to the servo that'll be up there. We also need a nose cone for our rocket. So, I don't want it to be too big. I'm going to be 3D printing the nose cone, so I don't want it to be too big, and because we don't want it super heavy. I don't know if I want to do a point or if I want to do like a curve. What do you guys think I should do? Should I do like a point or a curve? You know, because points, curves, a little different. Not too much effect on the rocket stability, I think, but we've got a thrust vectoring mount, so hopefully I should use purified oxygen in the nose cone. That's a great idea. Oh, like SpaceX, they had liquid oxygen in the nose cone of the SN10, I think, and like the first one that landed, and like you could see all the like frost on the top of the SN10, and then it blew up. But like that was kind of cool because the oxygen was in the nose, and our rocket's going to be like coming down on the side like the Starship. So that's cool. We could just copy everything off Starship. And they're both thrust vectored. It's a great idea. Alright, should I use curve or triangle? Which one? Anybody? Horrible idea. Why would you call my ideas horrible, Starduck? Don't like it, you know? Alright, curved or triangle? Anybody? Alright, let's go with curved. If nobody else has any objections with that. Because I think curved looks cooler, you know? Where's my water? I'm thirsty. Oh, I can't reach it, darn it. I have to go walk over and grab my water. Alright. So, I think that is all the designing that I have to do. No objection, except that cone is much cooler looking. Wait, which one? The curve or the triangle? Which one, Starduck? Which one? Alright. Yeah, so this week I'm going to work on finishing up my code and getting my barometer added to the flight computer. You think the triangle looks cooler? Really? Okay, wait a second. Alright, so the triangle will be like a bigger version of this. Do you think that looks cooler, or do you think like a curved top? And maybe like this isn't a very good model, because what if it's more like more of a taller curve, you know? Like a mix between the two. That drawing didn't really help. It's like a triangle, but at the top there's a curve, you know? Instead of a point. Like if we just took this and went like that. Do you like that? Or do you still like the triangle? What are your thoughts? Yeah, so as I was saying, this week I'm going to work on finishing up the code and adding the barometer and the light and the beeper. And then I'll work on building the parachute deployment system and the flight computer mount. And then after that, I'll print the nose cone. Oh, hi, Blip Blop. Okay, do you think I should go with the curved top, Blip Blop, or the, or like a triangle top? Like that, you know? Curved or triangle? Which one? Hey, don't say that. Okay, you think triangle looks cool. Triangle. Okay, I think we'll go with triangle then. I think the curve looks cooler, but like you guys think triangle looks cool, so we'll go with it. So it'll look kind of like this, except a lot bigger. And yeah. So this week I'll finish up building as much as I can, and then hopefully within the next couple of weeks I'll be able to fly this, and maybe sometime next week I'll be able to test out the what's it called? The parachute ejection system, like with the flight computer running, so just kind of like throw it up, and then as it starts to fall down, see if it'll eject the parachute. I would also like to add a function for like an abort in case the rocket starts to pitch too much to the side to make the parachutes fire, because that is very much a likely situation. How big is it? Here's the rocket, right? And the like inside diameter is 3 inches. So like the inside of the rocket, the diameter is 3 inches, and then long it is, oh, that's the wrong side. Give me a minute. it is 28 inches. And then on top, we'll add our nose cone. So that'll add a couple inches. Will its diameter be under 8 inches? For sure. Yeah, an 8-inch diameter is pretty big. Yeah, 8 inches is like that big. Like, I'm not building a rocket that big for a long time. Shishi. Yes, exactly. Do you guys have any questions about what I built? Sounds like fun, yes. If you have any questions, I'd be happy to answer them. Any questions? When will it be done? Let's hope, okay, let's think, it'll be at least 3 weeks. At most, hopefully, hopefully before February. Will it be done soon? Yeah, it'll be done soon. So, yeah, between the start of December and February. So, there's a 2-month period in there where I probably won't have it done by the start of December, but we can hope. Please stop spamming when will it be done. I just told you. Yeah, so considering that it's taken me 7 months to get this far, I'm super excited. I started this project in May and just finally got a working board. And that, if you guys haven't seen that, what's it called? The hold down test. That was so cool. I was a little nervous at the start because I was like, what if it just flies away? But it was super cool. Startup said, when can I play with it? You probably won't be able to play with it. It's not a toy. It's a rocket. All right, but yeah. So this is cool. I think I've got everything designed that I wanted to design. You've seen the complete saga, Blip Blop. Yes. Hopefully soon there'll be more to the saga. Yeah, so I got everything designed that I want to get designed. And I'll probably have a video on the parachute ejection system coming out in the next couple weeks as I build it up. Thank you guys for tuning in and chatting with me as I designed everything. It was a lot of fun for me. Hope it was fun for you. I will see you guys later. Goodbye.